Hello, and welcome to today's webinar, 4 Signs You Need to Upgrade Your Woodworking Design Software. This webinar is brought to you by Applied Software, the premier software systems integrator in North America. My name is Amy Worthy, and I'm delighted to be your moderator today. Throughout the presentation, we encourage you to interact with us by typing in questions and comments using the questions pane. Please take a moment to introduce yourself. We want to know who you are, where you're located, and anything interesting you'd like to share with us. Also use this box to type in any questions you may have throughout the presentation. We'll take time to answer your questions at the end of today's presentation. This webinar is being recorded and will be available to you online on our YouTube channel. We'll also send you an email following the webinar with a link to the recording. If you haven't already, search Applied Software on Facebook and Twitter. Connect with us to receive the latest information and special offers. If you need to create visualizations, renderings, or animations, but don't have the required time or software, we now offer visualization services like panoramas, photorealistic renderings, and more. We scope, produce, and manage the work for you so you don't have to worry about having the technical expertise in-house. For more information, visit our website on the bottom of the screen or email visualization@asti.com. Be sure to visit our website, asti.com, for more information on services and support, products and training like CAD learning and live lab learning, and more. You'll also find a complete schedule of upcoming events and webinars. Our upcoming webinars are Visualize Your Potential on Thursday, July 13th. That will be highlighting the visualization services I just spoke about. That's from 12:30 to 1:30. And we also have a CAD learning webinar, Getting Started with the Basics, on Wednesday, July 26th from 12:30 to 1:30 Eastern Time. At the conclusion of today's webinar, a survey will pop up. Complete the survey to be entered into a $25 Amazon gift card giveaway. You must complete the survey to be entered into the drawing. Now please join me in welcoming today's speaker, Steve Whittam. All right, Steve.
Okay. So, Amy, are they seeing my screen at the moment?
I do.
Okay, great. So, thank you for attending our presentation this morning. I'd like to introduce myself. My name is Steve Whittam. I represent Whittam Associates. We're a team member of the Applied Group that our particular focus and interest is in the work of woodworkers, the utilization of tools that Autodesk has presented that will assist woodworkers in becoming more productive, more efficient than ever before, utilizing new technology. We've always found that woodworkers lag a little bit behind others in adopting many of the new packages of software just because they're used to what they're used to, just like all of us. And to define change or introduce change into their world is somewhat upsetting, as we all know. I would just like to indicate that if we have a YouTube channel that has many other recordings, we have done presentations at Autodesk University, and they have other presentations, but everything we're doing here is specific for the utilization of technology when it comes to people creating at least 30% of their products in wood. And the focus is more towards the fabricator, not the designer, but even though they sometimes mix together, the efficiency of both really will allow us to quickly generate information that then can be machined, manufactured, routed, or panel saws and the like. So of course CAM is a large part of what our woodworkers need. So just to move on just a little bit, let's take a look at what I consider projects that woodworkers create. What you're looking at is a simple, maybe shouldn't say simple, but it's a spiral, semi-spiral stair that has been developed and designed for residents. You can tell just because the width of the stair is not as wide as you would have in a commercial environment. But the bottom line to everything that you see here is that this is real, and this can be fabricated down to the steel structure underneath that has, of course, been simulated with the utilization of one of our simulation tools to carry the load of the staircase. So again, what you're seeing here is not just a pretty picture, even though it is a pretty picture. It is the actual construction of what that stair would really look like in the home environment. You're seeing joists where it passes through the floor. You're seeing connections for balusters. You're actually seeing the true handrail and the twist of the handrail. So if we design this as we see here, we should be able to get an absolute duplicate copy in the real world conditions. Now, if I'm an architect, maybe I'm not going to get to this detail. I might just pass it over to a fabricator, and the fabricator, of course, will then design it and send it back a number of times for approval. But what we're trying to do here is minimize all those steps so that it's designed once, fabricated, built, and installed. And Inventor allows us to do that, even down to the level of volutes. Okay, these were not library items that we just pulled out of a catalog. These were all created. The core here is, if many systems allow you to design it, but not too many allow you to fabricate it down to the level of each tread is an individual part, as you can see here. The actual underlayment of the stair is correct. The stringers are correct. Everything is correct. And this will allow, again, automated machinery to machine this, cut it, mill it, and then we become assemblers that put things together. Again, this is more of a custom job, and if I was to guess, or at least tell you the amount of time it takes to accomplish this, I think you'd be surprised, because this is about a half a day's work to get to this point. And that's because we're using tools like Autodesk Inventor. Inventor was designed by Autodesk to be a fabrication tool, design to fabrication, rather than just an image or a picture of it. Every piece in here, down to the balusters themselves, would be movable and adjustable. Okay, the different lengths associated would be absolutely accurate. Cut lists and bills of material would be correct also as we work through this. So what you're seeing here is a fairly simple stair that at least some of our clients would do. But of course, there are many other possibilities here also, okay, of what one can create with it, which would be, I'll call it, normal construction techniques. What I'm going to do is move out of the rendering tool. That, of course, is part of the package. And I'll move into the core tool called Inventor itself. Now, more traditionally, if we take a look at a simple reception area, okay, this reception area, again, is, another form of woodworking. Maybe the marble countertops or the chlorine countertops could be fabricated by somebody else. But this core product that you're looking at is common across, all woodworkers that do anything with what are called die walls. If I move some of these panels away from each other, you will see that every piece of this construction is a separate part. Plates, ribs, finished ends, 45-degree corners, all of these are absolutely individual items. This particular model that we're looking at is 109 separate parts, and that's what the number at the bottom right-hand side of the screen is indicating to you. If I do a simple update, of course, all of that goes back together. And then if I click on these panels, right mouse, I can turn their visibility on and off. As we rotate it around further, I can take any panel or any item at any time and turn it on and off. So visibility of things can be manipulated very, very quickly. So I always challenge my, my prospective end users, and many of them come from an AutoCAD world or a 2D world, even a 3D world, and I say to them, if you were going to create something like this in the world that exists today, whatever you're using, and many of our users are using older versions of AutoCAD or even the latest version of AutoCAD, and I said if you were going to create a work package for the shop to build what you see here, how long would it take you to accomplish it? Because as a manager, managers sometimes all they care about is the time element. Time element, speed, accuracy, and hopefully not too many mistakes. A job like this, what I consider a work package, is a package containing front view, top view, sides, sections, details, cut lists, bills of material, fully dimensioned, ready for the shop to build it. Now, some of the things I haven't even finished yet, like the cabinet over here. So if you were an AutoCAD user or a different type of CAD user, and I said, please give me an idea of your estimate of time, you'll come up with some number. In our world, you know, and that's probably going to be more than a day for most people, because I'm not going to allow you to just open up an existing file, save it, and then just stretch it or do things like that. Let's say we start from scratch. Well, the job that you're looking at from start to finish is about 3.5 hours worth of work. So in 3.5 hours, in other words, I get in at 7 in the morning, by noontime I'm actually cutting material. Most of our AutoCAD users, and I've been an AutoCAD user myself over 30 years, cannot accomplish that task anywhere close to it. On top of that, one of the benefits of utilizing Inventor is that you see information before it's real. For example, you see grain and grain direction, okay? Obviously, you can see this panel is horizontal grain, this panel is vertical grain. And I have the ability to change the grain at any time. I also see the difference between exterior material and interior material. Again, in cut lists and bills, it's going to say that I have certain MDF or plywood, and in other areas it's going to say that I have finished panels. You can see that the top is totally independent. It's a Corian top or a marble top. And again, that's independent. So you also see seams. You see there's a seam all the way running down this entire piece, and that's because this grouping here is a subassembly, and it will be built independent of the rest of the job, because if you had to deliver this to the third floor, you couldn't get it in the elevator. So you had to have a way of slicing it apart and then putting it back together. And Inventor allows us to see all of that before we even start. So that's some of the benefits that we see going into the product. The other aspect of the job, of any job that I've ever dealt with, because my background, I was a professional woodworker, and you know, many of us forget there was life before computers. And because of that, you know, there are some core things that are quite unique here. For example, if we said that we'll start a job today on this project, there's a good chance within the first several hours, or at least a day after I start, someone will come to me and say, Steve, you've got to change it. You know, so change orders or change information in the middle of a job sometimes can bring a job to a standstill, costing time, energy, and what have you. But at least it's better to find that out before it's being machined. So let's say that my manager comes to me and he says, Steve, you know, you forgot to put in some cutouts in those ribs. These ribs here they don't have any cutouts in it. They have to be something like this, because we have to lose the weight of the rib, or we have to put some conduit or wiring or what have you into it. Now, what's nice about working in Inventor is that every part is independent. So here's a rib. It's independent. I just pulled it apart. And if I click on it and open it into its own file, you'll see that every single file is a separate part. Let me close out of what I was in there. So you could see here that you have an assembly with a rib in it, and you have the rib itself. Anything that I do to the rib will update the assembly. It's very similar to the concept of XREFs in AutoCAD. So if I was asked to cut a hole in the rib, similar to what I saw on the other side, usually the first thing I'm going to ask my manager is, where does it go? What's the size? How wide is it? How long is it? How deep is it? Before I'd even start. In the Inventor world, you can approximate where you want it, And then later, when you get the information, you can then finesse it, tweak it, tune it to meet your needs. That's why when we start out in one world like this, it's not that important to have all that information necessary to build every aspect of the job, which frees the user, the manager, the user, everybody up to look at it before it's real, make adjustments before it's real, and then when it's finally done, send it out for machining. So in this world here, if I was asked to cut a rib in here, cut a hole in the rib, I'm just going to touch the top of the rib and tell it I want to sketch on it. I can look at it from a top view or a side view or front view. I can be flat to it like many people in the 2D world. And what I'm going to do here is just very simply create a simple slot. So I'm going to grab a slot and place it. Now, the interesting aspect of this is I just threw a slot there. I didn't say how long, how wide. In fact, I'm just rotating, moving it around, and placing it. In our world, that's how simply we can start adding geometry. No coordinates are necessary. I don't have to say x, comma, y. I don't have to be exact because I then, with dimensions, control it. So if I wanted to physically locate this, all I would have to do is touch the edges of the slot and touch the top shoulder, and I'll say that's 2 inches. If I wanted to change the diameter or the radius, I'll say that's 3/4 of an inch. So now I'm going from decimals to fractions. If I say the distance from here to the side is 2 inches, it's now 2 inches, and so on until I fully configure what I want, and I'll say that this is 100 millimeters. So right online, at the same time as putting feet, inches, and decimals, I can actually now use metric. And what I did is I typed in 100 millimeters, and it converted it to 3.937 inches. But our tool also has the ability to change that on the fly. So if we say we wanted to see these units as metric instead, you can see that it automatically adjusted everything to metric. And being in a world of woodworking, many of the hinges and hardware is always going to be metric, and I don't have to do any conversions. So if I say this is 100 millimeters minus 1 1/8 inch, I can do my math right here, and it just converted it. Once it's converted like so, I'll pick extrude, touch what I want to extrude, and then just say I want to cut a hole in that part, and that's now done. If I don't like what I see, I can right-click and say edit the sketch or edit it. This is going to be 1 inch, and I'll say finish the sketch. Okay, so all these things allow for very, very easy usage of the system. Everything here is shareable. Everything here can be turned on and off. No layers are necessary because the tool is managing it for me. If I want more than one, a lot of times in other systems, you need to know what is the X direction and the Y direction. In ours, you just pick what you want. You tell it the direction you're going in. If you make a mistake, you can pick it again and say, I want to go that way. I want 3 of them at a spacing of, let's say, 3 inches each, and that's now done. If I didn't like what I saw here, I can say edit exactly what I did, and I just want 2 of them. But the spacing will be 3.5. So again, the goal is to have ease of use when I'm working in the system. Now I'll close out of this and go back to the assembly, and you can see everywhere that rib was used, you now have those double holes in those ribs. Looking at it from a side view, you can see that this is dead on and accurate. So your manager asked you to place these holes where you want, but then he didn't realize that they're a little too tight. In other words, I'm going to run conduit out the side of this part. So to do that, you now need to know what to measure. What is the distance? How tall are they? How high are they? And in our world, because you don't need O-snaps like you do in many of the other systems, you just touch the top of the plate and touch the floor, and then you see it's 6 3/4 inch. Or you can touch the floor and touch the center here, and that's 8.5 inches. So again, just very, very quickly generate information. Now, let's say that he said move it 2 inches up. That means you start a project, and after it's halfway done, there's somebody else who's going to change it. So to do that, again, all I'm going to do is touch the cutout, tell it I want to edit what was done. I'm going to change this to 5 inches, no, 4 inches. Let's go 2 inches up, and let's go 2 inches over. That's 2.5. And then I'll say finish and everything adjusts. Now, on top of that, let's say that we needed to cut through the side. We needed to cut through here. Okay, so again, it's fairly simple what we need to do, okay? We'll say what I want to do is take the existing holes that already exist by just touching it, and then by touching the cutouts here and here and say I want to cut through this, you could see that now I've actually cut through the side, and I'm creating accurate geometry that allows for the manipulation of our data. And nowhere am I doing trim and extend and offset and turn on layers or any of that. It's not necessary. Now, as we go, you know, I always considered Inventor to be a wonderful design tool. A design tool allows for you to change your mind in the middle of something when you see that it's not working out, or someone comes to you with different information and they need you to evaluate what was done and possibly make it better. In woodworking, every single job I've ever been on changed from where it started and where it ended. And I'll give you a good example of that. In this particular world, you might find that your manager comes to you and says, Steve, I need solid blocking between the ribs, okay? Solid blocking because I need to screw something through the panel. I need a handrail of some sort, and I can't possibly just go through the side panel. It needs to be blocked. So I have two choices of what to do. First choice would be, you know, put individual blocks through everything here, which would take up a lot of labor and a lot of time. Or what if I put a horizontal rib through all of these at once? Well, that makes the most sense. But again, because maybe I didn't start that way, I'm limited if I'm not using tools like this. So I'm going to create a slot here or a groove here and then create a horizontal rib on the fly. So to accomplish something like that, it's kind of simple. All I'm going to do is say I want to sketch on it. And this time I'll draw a rectangle starting from the edge and just opening it up like so. If I now measured it, and again, let's say it's a construction stud, so it's 3 5/8 by 1 5/8. And the distance from the bottom of the stud to, let's say, the bottom of the dado is going to be 12 inches. If I now extrude this, it's called, by just touching it, I can say I want to cut through that rib, and it's now done. All the ribs are done. Now, in many systems in wood, we can't get a perfect 90-degree cut. So what I can do is fillet this to marry the tooling of a machine to the design. So I just touch the edge and say fillet, and I can touch the top of the head of the arrow and just move it up and down like I'm doing here. Or I can touch through the part, and I can say that's 3/8 of an inch, 0.375. And that's now done. So what I just did here is all these things are really within 1 minute if I wasn't talking through it to start building. Now, the last step in this process is let's build the rib. So I'm going to say create a new part. Let's call it horizontal rib 1A. Give it whatever name you want. And I'm going to start the rib on this vertical rib. Once that's done, I'm going to use a simple tool called project, which allows you to touch the existing edges of this rib. And then I do have an offset tool, offset this inward 1 mil. So again, because I can be metric and imperial, I can type in 1 millimeter. Like a hatch pattern in many other systems, I'm going to just close this loop. And once that's done, I'll pick extrude, and I'll say I want to go all the way to this side here and pick OK. Now, looking at what I just did, which again is really very, very quick, you'll see that I've got a rib that's exactly 1 mil in clearance from the cutout. What I'm trying to show you is now if I move the slot, the rib will move up and down, and this is going to be used for solid blocking so that if I screw something into it, this will hold it. And because it's a centralized rib, With a clearance, it should be very easy to attach and assemble. But the best part of Inventor is looking at problems, or looking at, should I say, the possibility of solutions. How do you want to handle the corner now? Do you want to put a secondary rib going this way with a miter? Do you want to put a vertical rib in here? Do you want to use solid blocking? The point is you have all these alternatives so you can make the best choice for the company. Okay, let's go further with this. I'm going to rotate this around a little bit, and I am not using a heavy-duty machine whatsoever. This is a laptop I'm working on today. And if I now touch the countertops, if I click on it once, I can open the countertops into their own file. So what you're looking at here is a segregation of information. Now it could be the carcass, the cabinets, it could be the counters, it could be the doors, it could be the drawers. All of these are completely available at all times to manipulate. So if I just wanted to work on this left panel here, I can open that into its own file. So the linkages between all these different components are simple, and I don't have to go into Windows and look at folders. Everything's in front of me. Within our tools, we can do a bill of material right now. In our bill of material, this is providing me with information. For example, it is saying that the counter, which is a subassembly, is made up of the left counter, the corner, and the right. And the length, their width, and their thickness is all automatically being generated. By you just drafting, or I should say designing, it's automatically generating this information. You'll also notice that every one of these has the number of square inches, or converted to square feet, what it's made out of. All of this is available, and all of this can go directly out to Excel, because if you're going into an MRP or an ERP system, or if you're going into Autodesk Vault, okay, these are all available in reference to the ability to pull information out of the system. So what I'm just doing now is I just went into Excel. It's reading the information, and it's providing me with, well, it's not providing me with anything at the moment. I apologize for that. It could be that I picked the wrong template. Let me just do this one more time and go to Excel. Okay. And we use Excel for many of the things that we do. So if we look at the product structure, you see here that it's the left counter, the corner counter, and the right counter, and it's telling you exactly length, width, and thickness, and of course what it's made out of, and whatever color codes you might use. The parts list also is going to give you more information so that there's many features that automatically will generate from the usage of Inventor. I don't have to worry about after it's done going over documents and just manually typing in information. So let's say that your customer or your client or whatever looks at this and he says, Steve, you know, it's a nice design, but I hate the buts. He says to you that, you know, it's a nice counter, but I would like it to have a backsplash here, okay? Backsplash. And you say, you know, you say to yourself that that's not a good idea. I don't like it, okay? Then he says to you, on top of that, it should be post-formed. So the backsplash is part of the counter with radiuses in it. And now you say to yourself, that's the worst idea I ever heard in my life. Really terrible. You're a designer, you're a worker, you're hired by the company. You have three choices what to do at that moment. The first choice is just do it. Just do what they say. And you know it's wrong. You know it's going to come back and haunt you. You know it's going to get machined wrong. You know that when it's finally done, the customer's not going to like it. All those things based on your experience. But again, they told me to do it, I'll do it. The second thing is you can have a conversation with whoever asks you to do that and talk about the merits of doing it this way or doing it that way. That sounds good, except that you just lost a half an hour's worth of time. The best way, at least in my opinion, is why don't we just show it? Why don't we just build it? Why don't we just present it to whoever's asking right now for that approval? or maybe not the approval. But they'll see exactly the way it's going to be machined, and then they can make the choice. I don't have to make the choice, and I can do that. Now, why don't people do that? Why don't the vast majority, and I'm not saying all, but the vast majority of people don't do it? And the reason they don't do it is because, A, it takes too long. Maybe they don't have the knowledge in doing it, okay? And maybe it's too difficult to do. Well, in our world, that's about 30 seconds worth of work. And in 30 seconds worth of work, I can change the design of this model completely so that we can get a better, more efficient system that, A, can be built more efficiently, built cheaper, built better quality, and maybe make our end users happier about the end result. And the goal is, yes, let's get our consumers, whoever's the person purchasing whatever we do or viewing or whatever, have a much more comfortable environment. So for us, it's kind of simple. We touch the countertop and tell it we want to sketch on it. All these buttons that you see here are just right-clicking. And you can see that I'm hardly using any tools to do half my work. I'm going to draw a rectangular shape from the corner all the way to the seam. Now that's going to emulate the thickness of the counter, which of course is not too thick. I'm going to dimension that right now. So let me dimension the distance from the front of the backsplash to the back of the backsplash. And it shows up as 4 point something, which is wrong. I know that. What should it be? Well, I'm looking at the design. I'm saying it should be from this corner to that corner there. But I don't know what the measurement is, and I don't want to even check the distance. All I do is pick measure, and I touch back corner and front corner, and pick OK. And that's done. And then by touching it one more time, I have the ability to take this and actually move this arrow up and down so you can see what it's going to look like. So the first thing that I notice is I have a problem. I have an interference condition, and I know that's wrong. So if I had built it this way, when it comes back from the fabricator, this isn't going to fit. Yes, I know I can trim this back, you know, 1/8 of an inch or whatever is necessary, but then maybe it doesn't look right. Maybe this has to be mitered. Maybe. I don't know. So your manager says, Steve, no, just go to the underside. But you don't know what the measurement is, so you just say, I want to go 2, and you just pick where it's going, and that's it. And now that's 100% accurate. That's not close. That's dead on. But then you see a couple other things that are happening. For the things that you see happening are, you've got face grain here, you've got marble or stone here, and you've got side grain there, and it's terrible. To me, it's not acceptable. But in a world that you don't see textures and materials, you might have missed it. Okay, maybe not a veteran user, a designer, but one of the younger people that gets hired, they might not know the difference. And when you go out and machine all this, the last thing you want to know is that your customer's unhappy. But they also said post-form it, so I'm going to just fillet the outside, the inside, and the outside of this. And I'm going to say that this is, say, a 1-inch radius, and I pick OK. So this is what he asked you to do, and it's horrible. Okay, it truly is horrible. But you're showing him that's what he asked for, that's what he's getting, okay? Now in this world here, what's interesting about this is even if he likes this and he says go ahead and do it, then you, by rotating this model around and looking at this inside corner, you say, well wait, what are you going to do about that? And I hope that whoever told you to do it realizes that that's not going to work. Okay. Or it is going to work, but you've got to do a lot more changes. So what happens? So let's fix this now. So all this stuff was done. The browser, which is on the left-hand side of the page, is keeping history of everything. So if I go back to the fillet, I can delete it, and it's gone. But still, this is one piece. One piece. By touching this again and saying, I want to edit what's already been done, I can create what is called a new solid, pick OK. And the end result's going to be is that the backsplash is going to be independent of the counter. And that allows us to assemble it, you know, possibly independently or in the shop or in the field. What's also nice about this is if I touch this right now and open it, you can see that the counter plan is, of course, changing completely. So anything you do in the model will automatically update. But, you start getting better ideas. So what are the better ideas? Well, let's take this shelf, and I want to take this shelf, and I'm just going to pull on the arrow and say that shelf should go all the way to this end here, and pick OK, and that's now done. So you can see that you can do that with the tops. You can add more posts. All of that is absolutely doable as you start working with the system. Now, let's take this cabinet, for example. This cabinet right now is a very simple cabinet, nothing special about it. If I wanted to, I have the ability to assign materials. So if I said everything here is going to be made out of solid pine, and I pick Apply, this cabinet is made out of solid pine. If I want to change the grain direction of this of a bottom piece, I just touch the edge, and it now changes the direction. If I want to change the direction of this side panel, and I want to rotate it for book matching, 45 degrees, that's done. And then if I say that some of these other items are made out of different materials, okay, so for example, let's say that it's plywood. And I'm going to say this panel, this panel, this panel are made out of plywood. Okay, so which they are. And this back panel is made out of glass. I know it can't be, but you're seeing real as you start working it. So I don't want to see gray. I want to see real all the time. Now, in this particular environment here, I can start putting veneers and edge banding on things, okay? So if I wanted to put a individual piece of veneer, let's say I'm going to use this veneer. It asks me for the thickness of the veneer, and I touch this face, and I pick Apply. Okay, so I have a veneer face. Let's change it to something else that's maybe more noticeable. That's better. And let's say I put edge banding on something. Okay, what thickness edge banding? On there, you can see that right now what I've done is put a veneer on a piece of material, edge banded. The bottom is still plywood. The top is a laminate of some sort. And I'm going to pick Save. So what is it going to take now at this level here to actually go out to working drawings of what I see here? Well, first of all, if I did a bill of material, I'm going to get a different type of bill of material. It's going to list all this information. And the top stretcher, okay, you could see is made up of plywood. It has high pressure laminate, and it has edge banding as part of it. So all this stuff is happening all automatically as a user. The engineer, the designer, whoever is just applying material and is seeing it real. Again, you're working with real items all the time, real parts. And if I went to a bill of material now, it's listing what's made out of solid material, what's made out of plywood, what's made out of glass, what edge banding you have, what veneers are here, okay? And it's listing everything, and it's giving you either square footages or board footages or inches or lengths. Again, as you build, all this stuff is happening in the background with no programming whatsoever. Okay, going further with this, okay? Let's take this now and say, I want to create working drawings of this, okay? So we have tools here that do phenomenal automated processes, okay? And one of those processes is the ability to take anything, pull it apart, and create working drawings of everything that's here. And that's what I'm doing right now. So right now, you're looking at each individual part being laid out. The items that are angled at 45 degrees show up that way. You see the names. You see the quantities. You see the sizes, okay? And if we go into the other aspect of, you can see it's glass, okay? GL for glass. This is showing you the edge banding, in fact. This is showing you that that intermediate stretcher has edge banding on it, and that's what this is showing you right here. So how many notes do you have to apply before you can really tell somebody what to do or how to machine it? This is doing it for you. Now that's one type of plotting. The second type of plotting is each component to a separate sheet, okay? So in other words, maybe we don't want to lay it out that way. We want to lay it out one part per sheet where there'd be a front view and a side view and the title box and everything change immediately for you, okay? These are things that are possible with the utilization of Inventor and the woodworking tools. Works very, very well. So what I'm doing here is I'm now setting up the job to plot each individual part, okay? And in this world here, you see this is a top stretcher. It actually labels it, shows you the grain direction, and actually applies information in the title box. Side right, which is on an angle, okay, is really showing you the exact size of it, and it shows you that it's angled. Side left, which isn't angled, will show differently. The intermediate stretcher, again, is showing you the edge banding on it. So if you had 4 different edge banding panels on 4 different sides, you get 4 different values here. Very easy to print this, plot this, give it to the job, bring it into Vault, all the normal things that one would do. And again, all the rest is similar. Let's go further with this. I'm going to take this, I'm going to save it, and go back into my working assembly, okay? Notice it's been colorized, it's been, I've got the grain and the grain direction, all that's done, and guess what? You see it here. Yes, I was working on it independently, but we see it here now. Let's move into working drawings of the entire assembly. I wish I had more time, but again, I'm trying to give everybody an overview of the capability of why I'm thinking that you should consider the possibility of updating your software. If you're not using tools like this, and there are other products, of course, that are out there today, but Inventor is seamless. This creates AutoCAD drawings. It reads AutoCAD drawings. It is, again, very cost-effective. All those things are available to consider. If I said I want to start a brand new drawing, DWG. This is more like paper space. If I don't like what I see here, you know, the borders, title box, this is Supervisor Steve, this is all automatic, what fills in. Any of these things can be adjusted by just going in and saying I want to delete the border, bring a new border in, or let the system create its own. You want to say insert a border. No, this time I don't want zones. I'll say that this is going to be 0.5 borders all the way around. And quite simply, it's done. And there we are. Let's go ahead and create some views, okay? Now, I have the floor turned on so you see the floor as part of it. If I go back to the model and turn the floor off, and then come back here and create a base view, then of course it's coming in without the floor. Because the relationship between the model and the drawings are 100%. So when I bring it in, I can give it a name. I can say it's front view, just for lack of a better name. I can say I want to see it. The scale, 1 inch equals a foot. I can just type it in here. And then if I want a side view, I can just move to the right, a top view, and an ISO view, and pick OK. So again, what I just did here in seconds is create all my views. If I move a view, it moves the projected views with it. If we want to move this up, we just move it up. Double-clicking on it, you can change the scale of any view independent of the others, which is what I did, and you can turn on the labels if you would like. Views like these, sometimes you don't like them shaded, so we can turn the shading off. Okay, and this is more like many of the systems that people have. You can say, I want to see the hidden lines, and that's done. Now, going further, let's do some dimensioning. And in our dimension, we know that in AutoCAD, we have about 11 different types of dimensions. In most CAD systems, you have many. In our system, we use for woodworking maybe two or three. So for the first one, let's say I want to do some baseline. I just go near the object. I'm not snapping to it. I'm just going near the object like I'm doing now. Right-click and hit continue, and you can see that what I have immediately is a baseline. If I don't like the dimension styles, of course, I can change it to architectural, I can change it to fractional, or I can say millimeters, or any number of different combinations, and that's completely up to me. If I forgot to add a dimension, I can right-click and say add a member, and I can touch, and I can touch. And all these dimensions really clean up very, very nicely. If I take a dimension and push it, it pushes the other ones out of the way. So this is lining it up perfectly. And if I take a dimension and push it into a leader, it breaks it automatically for me. But then people always will say, Steve, why did you start on the right-hand side? Start on the left. Well, all I have to do is right-click on it and say make that the origin, and now that's the origin. It's done. Going further, let's do some continuous dimensions, or what we call chain dimensions in Inventor, and that's just put a window through what we want and pick continue, and that's now done. If we want to add one, we can say add a member, and I'm going to add this side, and that's done. If we don't like the fact that it pushed it to one side, we can touch it and say options leader, and that's now taken care of. And then of course this moves up and down. Taking it further, we can start dimensioning individual items. I'm just touching items, just touch. If I touch two lines, 1 and 2, it's automatically an angle, so it's not a separate dimension tool. If we touch a radius, it's automatically a radius. If we touch a diameter, it's automatically a diameter. So again, the usage of these tools are quite good. Again, if we want to say the center is the origin, let's make that the origin instead. Let's go further. We do have the ability to dimension isometrics. So here, what I'm doing is I'm dimensioning isometrics right now. Everything here is real at all times. You can take isometrics. You can right-click on this and say copy. You can say I want to create a new sheet, and I can say paste. We've got a new sheet, and the dimensions come with it. And if we open up, if we scale it up, like I'm doing here, by just touching this arrow, all the dimensions stay accurate and at the correct size. Let's come back here, and let's come back to sheet 1 again, okay? If we go back to sheet 1, let's say on sheet 1, I want to get rid of that because I don't need it on that sheet, so that's gone. Let's say we want to create a second view of this, okay? All we have to do is click on this once, right mouse copy, right mouse paste, okay? And of course, in many worlds, it's kind of tough to line them up, but in ours, you right-click, and you say, what I'd like to do is do an alignment horizontally to that. So now we have an alignment that locks to them. Now in this view, I want to turn the panels off, and because each of these items are separate parts, I have the ability to come to the browser here, find my panels, and turn off each of the parts that I want on or I want off, and turn off that. As you can see here, it's a glass back. Remember, I made it a glass back, so you see through it. Or maybe I don't want the cabinet at all at this moment, so I can say turn off the visibility of the cabinet, and that's off. And then here, start dimensioning it, and that's now done. Okay, let's go further with this. I'm going to take this view and just shove it off the screen for the moment. I'm going to move this view over to the right, and let's do a section while I'm here. So what I'm going to do here is section this view. So I'm going to put a section line through the cabinet, right-click, and hit continue, and come over here to the right, and now I have a complete, accurate section of what I just did. So as you can see that I'm really minimally doing a lot of drafting to get what I want. Now, if the shop wants to see this, okay, how do you build it? Well, let's project this view so you can give the shop isometric sections. Kind of neat when you can just send this off to the shop like that. And then if the section line is in the wrong place, I can move the section line and everything updates. Let's do some details while I'm here. So I'm going to detail this area. And I'm going to put my detail over here on the right-hand side of the page. Obviously, I have a lot of options of how I want to present it. And if I want to detail a detail, I'm now detailing a detail. What's nice about this is if you move a detail, of course, they're still lined up. And if you made a mistake and you detail the wrong item, you can take the master and move it, and everything adjusts. And then again, if you start dimensioning something like this post at 1-inch diameter, and this post at 1-inch diameter, and this post at 1-inch diameter, all the different possibilities of different scales and different annotation heights are gone. This works great. Now, everything you see here is an AutoCAD drawing, okay? Everything. So if I now said File, okay, and I save this as an AutoCAD drawing, and the reason I'm saving it is to go all the way down to AutoCAD 2000 if I want, or to DXF, because we can output this very, very easily. And I'm going to put this on the desktop, and I'm going to call it 12A1, okay, and pick Save. Then what I just did is I created an AutoCAD drawing, because as I said before, what you're seeing here is bidirectional. You can create stuff in Inventor, move it into AutoCAD, or move stuff from AutoCAD into Inventor. So let me just open up AutoCAD so you can see what just happened here. Okay, so we're getting near the end of our time, but there are just one or two more things that are, I think, critical to consider. The most important thing is ease of use and accuracy, because obviously everything I'm doing is really incredibly accurate. I mean, we're down to, well, I'm usually down to a 32nd of an inch, at least in wood. If you take a look at this is AutoCAD now. This is the same unit in AutoCAD. Dimensions are dimensions, so if we move this, right, you can see it's a dimension. Hatch patterns are hatch patterns, so if I just double-click on a hatch pattern, you'll see that this is fully controllable, and it is editable where I can actually start removing things, okay, and manipulating them, okay? So in a world where we have Inventor users and AutoCAD users and let's say any other CAD users, the universality is definitely there. Okay, last step. Let's go back to the model. Okay, in our model, our client says to us, Steve, I need you to radius this and bullnose it, okay? Radius and bullnose it. Okay, and this is the job's almost done. Well, what we do here is we just touch what we want to work on, which is this vertical line, and we say, we can just push on this arrow, and we can say that this is 12 inches. And that's now done. We can touch this top edge and say bullnose it 1 inch. And it's done. Okay, so it looks pretty good. But the key here is, would you, the user, have realized that this overhang here is a problem? Maybe in the world you're in, you could have done that, and then when this gets shipped out from manufacturing, it comes back this way because you forgot to reduce the backsplash by a certain distance. In our world, if I open up the counter plan, you're going to see that is absolutely wrong. So in our world, what we now normally would do is we touch what we want to work on, okay? Okay. And we can say that what we would like to do here is offset this edge by 1 inch. And that's done. Now the same thing could happen with the this shelf. So what we do is we say offset this by 1 inch. We're not adding, we're removing. Looking at this from this side view now, you see that this is dead on and accurate. The best part of it is if you go change the model at any time, it will update all your drawings. So if we go back to the drawings, you'll see that every single one of these drawings have been updated now. And then if you want, of course, put some dimensions on it, we could. Okay, so if I say dimension that or dimension this, you can see that's done. And every page, if we go to page 2, page 2 has been updated. So sections, details, everything has been done. The last step, and then we'll end our session, is this cabinet, okay, that we were working on before. This cabinet here, let's open it up and take a look at it. Let's go ahead and from this cabinet, file new, and say I want to start it. No, I'm going to go back and bring this cabinet into the other set of documents that I have here. I'm going to move this over here to the left, and I'm going to say I want to create another base view of this cabinet. Let's make it so, and pick OK. I'll shade it. I'll balloon it. Okay, what does that mean? Well, auto balloon this, everything in here. Okay, I'll select where I want the balloons. Pick OK. Each of these balloons are adjustable. They are all unnumbered. And if I then create a parts list of what I just did here and pick OK and place my parts list, you're seeing here a complete parts list has already been generated, and I put it on the drawing. Here's the glass back panel here, the size of the width, the thickness, and all this information is already done. So where are we when we look at all this stuff, okay? Where we are at this moment is a tool that is an essential tool for fabrication as well as true documentation. And whether we start with the staircase that I showed you, which is the most unusual non-rectilinear item, most custom thing you can imagine, to the very standard drywall considerations, okay? You have the ability quickly to generate information. And it's my guess that you should be able to increase your throughput approximately 30 to 50% in the first year. That is what we've seen. I work with woodworkers throughout the U.S. and Canada. We've been doing it for quite some time, and once people start looking at the usage of these kinds of tools, this is a flagship product from Autodesk. They start loving it, and they start realizing that they see exactly what they're building, and they get out of trouble before they find themselves building things and throwing material out in time. So, Amy, from this, I'd like to pass it back to you, if that's okay.
All right. I'm not seeing any questions currently. Please type those in if you have any questions. If not, feel free to reach out to us for any questions you may have later on. I'll give it another few seconds to see if anyone has any questions.
Right. And if anybody has any concerns or they're working on a particular project and feel that maybe this could be an alternative to the way they do things today, please get in touch with either of us. Be happy to do a one-on-one conference call to discuss the unique requirements that you might have.
All right. I will go ahead and conclude this webinar. In a moment, our survey will pop up. Complete the survey to be entered into a $25 Amazon gift card giveaway. You must complete the survey to be entered in the drawing. It'll only take a couple of seconds. Thank you all for joining us today, and thank you, Steve, for sharing your knowledge. We appreciate you all, and we hope you found this webinar informative and helpful to your business. We look forward to seeing you on a future webinar.